Our next speakers are Indrani Ghosh and Christina Perez, who are GIS modelers and analysts for Kleinfelder, which is a consulting firm, engineering, architecture, and science consulting firm in the Western US, and they'll be talking about redesigning for climate change. Welcome.
Good afternoon, everyone. Thank you for being here. The topic for our presentation today is redesigning for climate change, and we will be talking about how we can use GIS and the concepts of geodesign to do this. This is a brief snapshot of some of the recent projects that we've been involved with in the greater Boston area. And what has really formed in the last couple of years at the inception of these projects is the frequency of occurrence of some of the extreme events that we have seen, for example, Hurricane Irene, Hurricane Sandy, Nemo more recently. We've been involved with sea level rise and storm surge vulnerability assessment with the Army National Guard, Camp Edwards National Guard base in the Cape Cod area. We're also helping the city of Cambridge to help them design a climate change adaptation plan for the city for the 2030 and 2070 planning horizons. Recently, we completed a study in the 3 coastal towns on the south shore of Massachusetts doing a sea level rise modeling study for the towns of Scituate, Marshfield, and Duxbury to understand what the most vulnerable publicly owned infrastructure in those 3 towns and what the town officials can do to protect them. And last but not the least, we're also involved with the Massachusetts Port Authority. We're developing a disaster infrastructure resiliency plan for Logan Airport and the Mass Maritime facilities, helping the client to harden their infrastructure. So what is it that has led cities and towns, clients, different state agencies to think about climate change and impacts on infrastructure? This presentation will be focusing a little bit more on infrastructure. So what is it that has caused them to think more? So our infrastructure traditionally has been built on the assumption of a very stable climate. This is a schematic, very simplistic representation of how, historically, there have been natural variations in climate, but these oscillations have more or less leveled out, so the net impact has been fairly constant. But not happening anymore. What happens if that climate is not stable anymore? Now, we see more natural variations, we see more variability, but they don't even out anymore, and there's a net increase effect, which means higher intensity of storms more frequently occurring. The infrastructure that we have designed, the bridges and dams designed for a 100-year design life, our conveyance system for a 25-year level of service, we've built buildings above a certain flood elevation, but the definitions of those thresholds are changing. So these are some of the climatic parameters that we consider to do climate change vulnerability assessment studies. Temperature is one of a major climatic parameter, global warming as we know it. We study temperature from the aspects of heat waves, days over 90 degrees, 100 degrees. Precipitation, more frequent, more intense storms, changes in recurrence interval of design storms. And that is probably a little more relevant in the Northeast, which is projected to be more wetter and higher intensity of storms. But on the other side of the country, in the Southwest, we were expected to see more drought, more arid conditions. So we would just see an intensification of extremes. The other parameters that we look at are sea level rise, intensification of storm surge, and high winds. So how is it that we translate this complex science of climate change into something that our clients can use, and use that to define implementable design solutions for them that they can use to protect their infrastructure? For this, we use a very simplistic 3-step approach to do this vulnerability assessment. Step 1, the climate change projections, this is where we use the ensemble of global climate models, use of appropriate downscaling techniques, and understand which exact climatic parameters our clients are most interested in. From those, we develop scenarios for different planning horizons, determine which climatic parameters to consider in those scenarios. Next step is to do the vulnerability and risk assessment. Vulnerability is a combination of sensitivity and adaptive capacity. risk a combination of probability of occurrence and the consequence of the impact. High risk, high vulnerable areas on the top right corner find their way into the priority planning areas. And those are the areas that the clients will focus on to develop adaptation strategies and to come up with implementable solutions, because as we know, resources are limited. So we use GIS in all of these steps to analyze the impacts, to visualize the impacts, and what better way to engage decision makers and stakeholders than GIS to come up with climate and resiliency risk planning. And this is, again, a snapshot of the South Shore project that we recently completed. On your left-hand panel, you see this is a snapshot of the Scituate Harbor area. This is downtown Scituate. It shows the impact of sea level rise by about a foot of sea level rise in 25 years from now. Right-hand side panel, sea level rise and storm surge from a Category 1 hurricane. And Sandy, just to bring context, was a Cat 1 hurricane when it struck Atlantic City at high tide. And so you can see the extent of devastation and how we can visualize these impacts. And now that we've understood or assessed the impacts, how do we come up with a metric or a vulnerability score to assess these impacts? This is an area of East Cambridge, and it has been, the inundation scenario is sea level rise, again, a Cat 1 hurricane. At the center of your screen, that yellow polygon is a substation in East Cambridge, and the area is flooded. So again, vulnerability is a combination of sensitivity and adaptive capacity. Sensitivity is the extent to which the functionality of the system is going to be impacted. And yes, it is a substation, so it being flooded, the sensitivity score is very high. Adaptive capacity is what is the redundancy in the system. Well, if there's a backup generator at that location, maybe it has some sort of redundancy, adaptive capacity. But if the backup generator is at the same elevation as the main generator, maybe not so. So it has a high adaptive capacity, high sensitivity. It has a low adaptive capacity, high sensitivity, which means it gets a high vulnerability score. And finally, once we've assessed the vulnerability of the system, the impact of this system getting affected is much larger than just that asset. It's a much more cascading impact. So all of those areas in East Cambridge that are served by that particular substation are going to go down. So the risk associated with that system being affected is much larger, which is the area shaded in red. So the subway stations, schools, hospitals, residential facilities are all going to be affected by this power outage, and hence this gets assigned a very high risk score.
Thanks, Indrani. So Indrani is talking about assets, infrastructure assets that are failing and consequences, what's going to happen if that asset fails. And this brings us a little bit towards the asset management arena. And what we're trying to do is to bring the services that we provide also in our company about asset management to another level. So when you do asset management, the main goal is to optimize your operations and maintenance and operate your budgets pretty much. So run all your system at the optimal level and extend as much as possible the life of your assets. Usually, after an implementation of an asset management program, you have the ability to prioritize or do a risk-based prioritization of your capital projects. And that lets you plan for like your 5-year or 10-year kind of horizon. But the idea is like, let's bring in all these concepts and all these analyses from climate change and build them into the same asset management system and see where it takes us. So we're going to recalculate all these risks scores going forward, a little bit forward down the road. So not just looking at, oh, this asset may fail because it's too old, but what if it fails because of all these other impacts that can happen? To that, we need to start changing a little bit the models that we're using for this analysis. Usually when we implement an asset management program, we start with a data model. We are very fond of the Esri local government data model. We take that data model and we customize it to meet our clients' needs. And what we are trying to do now is keep customizing it and keep adding assets, asset types, and adding attributes to this data model to make it suitable for calculating all these new risk scores that are going to be linked to the climate change impacts. Some of our clients are very interested on their facilities, so one of the aspects of that is going to be adding facilities and facility assets into this data model. So once the assets and the facilities that are going to be impacted are all identified and the prioritization is done based on this risk approach, the idea is now to do the last part, which is where the geodesign tools come up, which is come up with the adaptation strategies. And those are going to depend, obviously, based on the asset type that we're talking about and the impacts that we are talking about. And ideally, we want to try to be efficient, and if we can mitigate several impacts with one strategy, that would be the best. Here we have a couple of examples. For example, with pavement, pavement can provide a lot of heat island effect when it's like black asphalt surfaces. So maybe changing those to other type of materials. Maybe concrete would be lighter and would contribute less. Maybe you can use porous pavement that would also be better for infiltration purposes. We look at also individual assets like buildings and decide, okay, maybe all your equipment, it's on the basement, it's going to be flooded. Maybe you should think about moving all these systems and equipment to a higher level, put it on the roof, and implementing all these low impact development practices that we are all familiar with. I want to finish this talk saying, okay, this has been very focused on the infrastructure, but we don't forget about social resilience and health and all that type of stuff. These are all consequences, and they are built in our risk model as consequence factors. And here is a graphic of one of the vulnerability assessments to heat island effect that we conducted for the city of Dallas.